Killer asteroid coming in 8 years. How worried should we be? Imagine a space pebble the size of a 15-story building wandering through the solar system as nonchalantly as a tourist on vacation. This is 2024 YR4, an asteroid with an estimated diameter between 40 and 90 meters, 130 to 300 feet for the fans of imperial measurements. Discovered on December 27, 2024, by the Chilean station of the Asteroid Terrestrial Impact Last Alert System, or ATLAS, this object was quickly classified as an Apollo-type near-Earth object, meaning it crosses Earth's orbit and could potentially say hello a bit too closely. But wait, there's more. On February 12, 2025, 2024 YR4 has reached level 3 on the Torino scale, the system that measures the risk of collision with Earth. The Torino scale ranges from 0, sleep easy, to 10, pray, and level 3 is reserved for situations with a relatively low but significant probability of an event capable of causing localized damage. To give you an idea, it's the second highest rating ever reached by an asteroid after 99942 Apophis, which nearly hit level 4 in 2004. But hold on a second. What's up with this name? The designation 2024 YR4 sounds like a cheat code for a game, but it actually makes sense. 2024 is the year of discovery. Y indicates the second half of December, and R4 means it's the 117th asteroid found in that period. Essentially, it's like astronomers have an infinite shopping list, and this is item number 117. A useful classification tag, sure, but definitely a hassle to mention 100 times in a video. So how about we just call it YR4 from now on? Great, agreed. Now let's get to the point. According to current data, YR4 has a 1 in 45 chance, about 2.2%, of impacting Earth on December 22, 2032. Yep, you heard that right. A 1 in 45 chance. It's like being told you have a 1 in 45 chance of getting hit by a car if you sleep outside today. Would you feel calm? Probably not. And indeed, this asteroid has become a major concern for the world and a huge focus for the scientific community, which is tracking its trajectory with the same attention you'd give a reality show full of plot twists. The discovery of YR4 triggered the first steps in planetary defense responses, prompting telescopes worldwide to gather data on the object and pushing UN-supported space agencies to start planning threat mitigation. It's like discovering a water leak at home. First you worry, then you call the plumber, and finally, you watch YouTube tutorials to figure out how to fix the problem. But here, we're not talking about a broken pipe. We're talking about an asteroid that could cause significant damage if it collides with Earth. So, what's next? This video might reveal that things aren't exactly as they seem. Because as you'll discover, there's much more to know about YR4 than you might imagine, between possibilities, computer simulations, and emergency plans. Ready to find out? Let's dive into the data. So, YR4 is a stony asteroid, basically a giant rock drifting through space, and it spins like a mad top. It completes a rotation every 19.5 minutes. Essentially, if you were on its surface, spoiler, don't, you'd see sunrise and sunset every 10 minutes. Kind of like those time-lapse videos on Instagram, but without the filter. Now for the facts. On December 25, 2024, 2 days before it was discovered, this asteroid almost brushed past us, zooming by at 828,800 kilometers or 515,000 miles from Earth, about 2.15 times the distance to the Moon. A close call, but nothing dramatic. After this quick hello, it's now moving away, and it'll be back for another visit on December 17, 2028, when it'll pass at nearly 8 million kilometers or 5 million miles away, 20 times the Earth-Moon distance. So, a more relaxed meetup, like a Facebook like after years of silence. The issue? From April 2025 to June 2028, YR4 will be too far to be seen by ground-based telescopes. It's like when your friend goes to Australia and falls off the radar. However, space-based infrared telescopes like the James Webb can still keep tabs on it. In March and May of 2025, JWST will watch it like a paparazzo stalking a celebrity. How big is it? Well, we don't know exactly. Imagine trying to guess the size of a car by just seeing its headlights at night. The dimmer it is, the bigger it is. If it reflects between 5% and 25% of the light, like asphalt or concrete, its diameter ranges from 40 to 90 meters, or 130 to 300 feet. NASA estimates 54 meters, or 177 feet, about an 18-story building, making it similar to the Tunguska asteroid, the one that leveled the Siberian forest in 1908, or the one that created Meteor Crater in Arizona. To know for sure, we need thermal radar observations or a space mission. Basically, we either scan it with infrared or send a drone to take a selfie. But let's talk about the impact probabilities. As of February 15, 2025, after 45 days of observations, there's a 1 in 45 chance, or 2.2%, it'll hit us on December 22, 2032 at 14:02 Coordinated Universal Time. Essentially, it could pass at 160,000 kilometers, or 99,000 miles away, less than half the Earth-Moon distance, but with a margin of error of 700,000 kilometers, or 435,000 miles. Like saying I'll arrive between 2 and 4 p.m., but then showing up at 6. And this sparked the chaos. At the end of January, the probability was 1.3%, then it climbed to 1.7% in February, then down to 1.4%, up to 2.3%, and finally stabilized at 2%. A statistical roller coaster making everyone think, is it playing dice with our destiny? Yet scientists seem to downplay it. And here comes the question, why do they seem so calm? Well, according to them, the initial rise in probabilities is normal. It's like when you turn on GPS on the highway. At first, it says exit in 500 meters, but as you get closer, it refines the calculation. Initially, with few observations, the possible trajectories are numerous, some towards Earth, but as more data comes in, the map becomes clearer. So yes, the probability can rise at first, but it's just because we're zooming in on reality. No, it's not a conspiracy to keep us calm. It's just that science works this way. The more data you have, the more precise you get. And while we on social media tend to exaggerate and scream danger, they're already working on plan B. You know, like, still not convinced? Okay, let's use a practical example, like one your science teacher would use to explain something complicated. Imagine being in a theater. There's an actor on stage, and you need to spotlight them. At first, the beam of light is huge. It lights up the actor, but also the backdrop, chairs, microphone, and even the janitor's cat snoozing in the corner. This beam represents all possible future trajectories of YR4. Earth is the actor, and the rest is the space around. Initially, the actor, that's us, is just a small part of that illuminated area, so the asteroid could hit us as much as it could miss us. Then, the lighting technician, aka the scientists, narrows the beam. Now, the lit area is smaller, and if the actor stays in it, they cover a larger percentage of the light. Translation: the more observations you make, the more you narrow the possible trajectories. If Earth remains in those trajectories, the probability of impact increases, even though the total number of possibilities has decreased. That's why initially the probability was 1.3%, then climbed to 2%. The beam narrowed, but we're still in the spotlight. But don't worry, the more data comes in, the more the beam narrows, and eventually Earth might completely exit the illuminated area. Now let's talk about YR4's destructive potential. 3 factors come into play here: composition, speed, and mass. Unfortunately, at the current distance, we can't measure them precisely. So scientists make estimates using the diameter, mass, and density calculated by NASA. They say if it were to hit us, the asteroid would release energy equivalent to 7.7 megatons of TNT. To give you an idea, that's 500 times the Hiroshima bomb. Sounds like a lot, but it's not enough to wipe us out like the dinosaurs. YR4's stony composition means it would likely disintegrate in the atmosphere, creating an airburst similar to the Tunguska event on June 30, 1908. That day, an asteroid about 50 to 60 meters or 164 to 197 feet, about the size we're talking about here, entered the atmosphere at an insane speed and exploded 5 to 10 kilometers or 3.1 to 6.2 miles above the ground. The explosion released energy equivalent to 10 to 15 megatons of TNT, about 1,000 times the Hiroshima bomb, and the shockwave flattened 80 million trees over an area of 2,000 square kilometers or 772 square miles. The nearest witness, 65 kilometers or 40 miles away, reported seeing the sky split, a great fire above the forest, and shortly after, a tremendous roar and air blast. The noise was heard up to 1,000 kilometers or 621 miles away, and on the Trans-Siberian Railway, 600 kilometers or 373 miles distant, a train was overturned. Even in London, where it was midnight, the sky lit up. Thankfully, the area was nearly uninhabited. Otherwise, it would have been a massacre. And the crater? None. The asteroid disintegrated in the air, leaving only a huge scar on the Earth. Then there's the meteor crater in Arizona, formed 50,000 years ago by a nickel-iron asteroid, also about 50 meters or 164 feet in size. This one, being made of iron, wasn't stopped by the atmosphere. It hit the ground at a speed of 12.8 kilometers per second, or 28,600 miles per hour, and carved out a crater 1.2 kilometers, or 0.75 miles wide and 170 meters, or 560 feet deep. Imagine a hole the size of 20 football fields and as deep as a 50-story building. The energy released? About 10 megatons of TNT, similar to Tunguska, but with a direct impact. If it had hit a modern city, it would have been an epic disaster. And let's not forget the Chelyabinsk meteor in Russia, February 15, 2013. Today marks the 12th anniversary of its fall while we're recording this video. That object was smaller, about 20 meters or 65 feet, but it entered the atmosphere at 19 kilometers per second or 42,500 miles per hour and exploded at an altitude of 30 kilometers or 19 miles. The explosion released energy equivalent to 500 kilotons of TNT, 30 times that of Hiroshima, and the shockwave damaged 7,200 buildings, shattering thousands of windows. More than 1,500 people were injured, mostly by flying glass. The kicker? No one saw it coming. It arrived during the day from the direction of the sun and caught us off guard. The moral of the story? Asteroids are like trucks on the highway. Sometimes you see them coming, sometimes you don't. Fortunately, we're monitoring YR4, but Chelyabinsk reminds us that the real danger could be an object we haven't discovered yet. Anyway, despite the rising probability of impact, the situation isn't yet a catastrophic movie scenario. Similar situations have occurred in the past and often resolved with a resounding no big deal. Take Apophis, the asteroid discovered in 2004 that initially seemed to be heading straight for us in 2029. After months of observations, scientists ruled out any risk of collision. The same might happen with YR4. Or maybe not. Who really knows? Suppose that in 2032 the current optimism of scientists is resoundingly disproved. What could we do? Do we have the means to stop this pile of rubble heading our way? And how? If we can't stop it, could we at least calculate the impact point to change or address and move in a hurry? Okay, let's try to answer. First of all, yes, we have plans. We're not completely defenseless. And no, they don't involve Bruce Willis with a nuclear warhead, though we get pretty close. Here are the options on the table. Kinetic impact. It's the most tried and true method. In 2022, NASA's DART mission demonstrated that we can deflect an asteroid simply by crashing a spacecraft into it. Here's how it works. You send a spacecraft to smash into the asteroid at a crazy speed, and the impact nudges it slightly off course. Small nudge, big effect. Over cosmic distances, even a minimal change can make it miss us by millions of kilometers. Gravity tractor. If the asteroid is too big to be moved by an impact, we can use gravity. Put a heavy spacecraft near the asteroid, and its gravitational pull will slowly nudge it off course. It's like an elephant moving a mountain, 1 millimeter at a time. It would take time, but it works. Or, for a faster solution, land a couple of spacecraft with powerful thrusters on the asteroid's surface. Once fired up, the thrusters would alter the trajectory just enough. Nuclear explosion. This is the Armageddon solution. If all else fails, we could use a nuclear warhead to shatter or deflect the asteroid. But it's the last resort because there's a risk of creating many smaller, harder-to-track pieces. And let's face it, it's not the epitome of space diplomacy. Fresh paint. Sounds like a joke, but it's a serious proposal. Cover the asteroid with reflective paint, and the pressure from sunlight will slowly move it. It's like sailing a boat in space. Slow, but effective. How long would it take? Depends. If we act 10 to 20 years in advance, but we're already cutting it close, even a small nudge might be enough. If we wait until the last minute, we'll need to go nuclear. Well, then it's every man for himself. The last chance would be to calculate the impact point a few weeks in advance. It's not much, but it's better than nothing. After all, some people are already working on it, and we're not talking about scientists in labs coat shouting "Eureka" in the lab. Take David Rankin, an engineer with NASA's Catalina Sky Survey project. He's already traced a risk corridor, a sort of imaginary stripe across the globe. According to his calculations, if YR4 were to hit us, it would fall within a band that starts in northern South America, crosses the Pacific Ocean, Africa, the Arabian Sea, and reaches Southern Asia. Basically a line that cuts the planet in half. Countries like India, Pakistan, Bangladesh, Ethiopia, Sudan, Nigeria, Venezuela, Colombia, and Ecuador. Essentially a list that looks like it's straight out of a geopolitical strategy game. If the asteroid were to hit, it would be a local disaster, but nothing apocalyptic. Sure, if you live in one of those areas, you might start thinking about moving, but for the rest of the world, it would be like watching a dramatic movie from your living room. Concerning, but with a certain detachment. Cross our fingers and hope the scientists are right. Because in the end, the real danger isn't the asteroid we know about, but the one we haven't seen yet. And while we worry, they're already working to ensure YR4 becomes just another story to tell the grandkids. Moral of the story? Don't panic, but keep an eye on the sky. And if you really want to do something, support scientific research. Because let's face it, it's better to have a plan B than to end up like the dinosaurs.